Hello everyone, and welcome to this live Austmine webinar. I'm Sheldon Varco, Membership Manager, New South Wales and South Australia here at Austmine, and I'm very pleased to host today's Mets Tech Talk on a zero impact future. This is the final Tech Talk of our Harnessing Intelligence series, which has focused on emerging technologies and breakthrough innovations that are enabling mining's transformation and driving our industry towards a sustainable future. We kicked the series off by exploring the interaction between people, processes, and technology in our first session, then delved into the power of data in our second webinar, before exploring the connected mine of the future in our previous session. You can view those recordings and register for our final session through Austmine's event webpage. For today, we have 6 companies joining us to discuss a zero impact future. And they'll be exploring a range of solutions that are driving the pursuit of sustainable mining operations globally. Joining us are the Circular Mine Consortium, Oleology, RWDI, Anderson Hauser, Alfa Laval, and JWA Oilfield Supplies. Following their presentations, there'll be an opportunity for audience Q&A. You can use the Q&A box at the bottom of your screen to send your questions over at any time during the webinar. If you have any comments, you can also use that chat box to share any of those with the presenters. You can also upvote on any of the questions that you most want answered, and we'll get to these first during the Q&A session. So as mentioned, today's session will be short and sharp. So I'd like to introduce our first speaker, who is Alison Price, Managing Director of Soil Cyclers, and she'll be exploring the Circular Mine Consortium. Thanks, Alison.
Thanks, Sheldon. Hi, everyone. As Sheldon said, my name is Alison Price. I'm the Managing Director of Soil Cyclers and a member of the Circular Mine Consortium. We're a partnership of Australian and European businesses, and we're one of the top 10 finalists in the BHP Tailings Challenge. Together, we've come up with a toolbox of innovative solutions for recycling mine tailings to help make zero mine waste a reality. So the Circular Mine Consortium includes European leaders in recycling and Australian mining expertise. We have a unique mix of researchers, engineers, business people, and we have in-house capabilities to cover everything from the laboratory analysis, extraction, design, sorting, testing, transforming, marketing, and selling of the recycled materials. So our toolbox includes many proven innovative technologies, such as a cost-effective bioleaching process to extract the remaining metals and minerals while also decontaminating the tailings. We can also produce and manufacture construction materials using carbonation technologies, and we've got the ability to remediate soils to the highest environmental standards. So our team has the expertise to scale up our processes to industrial scale. So this isn't just about recycling, it's also about creating a sustainable business. Our revenue streams come from the processing of the tailings, the metals and minerals extracted, the construction products, and the carbon economy, as well as water recovery and supply of topsoil. In many cases, we're able to create recycled products that the mine itself can use as part of rehabilitation of the site. We work with our mining clients to confirm the quantity of metals and minerals. Looks like I've gone a little bit too far with the slide, Sheldon. I'll see if I can take them back. Yes, I can. We work with our mining clients to confirm the quantity of the metals and minerals to be extracted, the sulfide levels, the carbon capture potential of the tailings, the potential construction materials we can make depending on the location of the mine that may or may not be suitable, and the soil volumes for rehabilitation, through a design of a flexible flow sheet, which demonstrates commercial feasibility as well as the scientific feasibility as well. So we're a group of environmental businesses who know the mining industry is necessary, but we want to transform its impact on the local communities and give them a long-term positive future. So based on the data and estimated volumes from some of the mine sites we've been talking to, we've estimated that we can capture 100 grams of CO2 per tonne of tailings, which is potentially up to 3 million tonnes of CO2 per year in the carbon economy. Our process will also neutralise contamination, which means that the tailings don't need to be stored in tailings dams with all of the associated risks and environmental issues. Our solution will improve the groundwater quality and also help mine sites with revegetation. Our values as a team include gender equality. We've got female-owned businesses and businesses that are performing very well in that space as part of our consortium. Developing innovative, sustainable solutions and working collaboratively with stakeholders. We're an unusual group of companies that have formed a collaboration specifically for the BHP Tailings Challenge. And that collaboration really comes through in the way we work with our clients. We've got plans to make opportunities for the local Indigenous population with training and employment opportunities as part of the new industry we can create around the mine site. So our recycling, mining and circular economy expertise combined with our vision and commitment to make zero mine waste a reality will guide us toward creating a major step in the transformation of the mining industry. Our solutions have the opportunity to deliver major environmental and social benefits, contributing to a safer, cleaner and more sustainable world, with mining recognised as an essential contributor to the circular economy. Look forward to answering any questions that you have, and I will hand back to Sheldon for the next presenter.
Excellent. Thanks a lot for that, Alison. It's been tremendous to see that collaboration come about through that BHP challenge, and very exciting to see where you guys are taking it into the future. So well done to that. And I see there's a question or two coming through already, so we'll get to those at the end of the session. I'd now like to hand over to Paul Callahan, who's the Director of Oleology, and he will be discussing removal of PFAS and oil from water.
Thanks, Sheldon. Oleology has been working in the space of oil removal for some period of time. Oil removal, why aren't we working there? That's better. So when we've been recognised for that for quite a period of time. PFAS is a relatively new persistent organic pollutant, which is of major concern to many companies around the world, and particularly here in Australia. It also has affinity as it is a synthetic organic with our MySelex technology. For this and for the work that we've been doing over the last 10 years in the PFAS area, we've been recognised for the technology and its impact on reducing both the outcome, but also doing it in a sustainable way. And that really is about removing PFAS from groundwater and from industrial wastewaters in association with other organics as co-contaminants, and being able to do it with a very low energy, very low waste, and in a staged, robust sequence, so it's low risk. So the size of the treatment system, the cost of operation, the waste generated, and the risk associated with our system is considerably reduced when compared to conventional systems that fall back on old technologies such as granular activated carbon and even ion exchange. So the important part of this is to reduce the waste component, and the waste that's generated, the number of trucking movements, the type of waste, by all accounts, the lowest risk that can be undertaken, in that the waste is dry, it's safe to move and store, it's the simplest and lowest cost to destroy, and that's done by thermal oxidation, thereby lowering the risks at site at handling for people in the environment, and also in the event of any residual wastes that might remain in the water. PFAS is a range of 6,000 compounds, some of them which are undiscovered as yet because of IP that's over the compounds themselves. And the selective affinity that is in some of the conventional technologies is surpassed by the way that we undertake our treatment, in that we're able to remove across the board. At the present stage of those roughly 6,000 compounds, only 32 are able to be analysed by commercial laboratories. So without a wide affinity, there is a very large risk, ongoing risk of future liability due to unchecked residual compounds remaining in the water. So in order to improve the environmental sustainability, the reduction of the carbon footprint is very important. Very low energy consumption in what we do. We lower the maintenance requirement, and that comes about as a result of direct work at site, but also the carbon footprint that's associated with maintenance through waste transportation. The volume of waste has a big impact on it, and the frequency at which the maintenance must be undertaken. And that also impacts the future liability and the rehabilitation. So all of those aspects are significantly reduced, and we can see that in a minute when we begin to look at the size of a conventional system that's actually in operation at the present stage, treating about 700 cubic meters of water per day. That is the size of the average football field. So there's a lot of risk. There is a number of tanks, lots of pumps, higher carbon footprint, and lots of liquid sludge waste generated from that type of plant. The 4 rectangles that are in place are the equivalent for the volume treated that is required for our system. The waste movements to site, the maintenance at site, the energy required for pumping and treating is significantly lower. In addition to that, we're able to treat, because it's organics, hydrocarbons, oil, fuel, BTEX, other organics of that type in the water, and organometals and PFAS with the same system. The affinity across the range is quite broad. The other thing that's important to mention is, because of the sequence of stage filtration, we remove any peaks which would otherwise overcome conventional systems in spikes and prevent them from affecting the polishing mechanism. So no matter whether it's a high level of contaminant in the groundwater or in the industrial wastewater, or a low level of polishing that's required, the same system can treat it to below detectable levels. So what something might of this type look like? On the left, you can see inside a 20-foot container, something that'll treat 155 cubic meters of water per day, or 155,000 litres, if you prefer to talk in litres. On the right-hand side, similar sort of system set up for a client using skids. Now, that's roughly 2 litres per second. Fits into one single 20-foot container. To treat something at 4 times that size, we just double the size. So very much easy to scale up with significant reductions in footprint as the scale increases. Importantly, the future liability in doing this is 0, as we're able to remove across the full range of contaminants. If you've got any more questions, please get in contact with us.
Excellent. Thanks a lot for that, Paul. It's terrific to see you tackling the challenge of PFAS, which hasn't just been a problem in mining, but across many industries, as we've seen. So thanks a lot for that. And do get in touch with Paul either through the Q&A or afterwards following the session. Moving on now, I'd like to introduce our next speaker, which is Francoise Robe. She's the Strategic Director of RWDI. And she's going to be talking about weather forecasting and advanced modelling. So welcome, Francoise.
Thank you, Sheldon. All right. Good afternoon, everybody. So weather forecasting and advanced modeling as tools to sustain operational management system in mining operations. So we're using a our expertise to minimize environmental impact. What's the challenge? A lot of the impacts are weather driven and hard to quantify impacts. So the solution we've proposed is based on weather forecasting. So we model them, we model the impacts, we forecast them, and then we put them in a visualization system, a website, where the operators can visualize, look at alerts, look at the different systems so that it helps their decision making. And I'm going to talk about different applications for air quality, dust, noise, and also fugitive methane emissions, quantifications, and targeted mitigation. Oops. So it all starts with the weather forecasting. Why is it moving forward? Oops. It all starts with the weather forecasting, and
Francoise, I might just be a delay on your end. I'll just pop through to the slide that you'd like.
Yeah, weather forecasting. Sorry. You're making it move. Sorry, weather forecasting at all kind of different scales in a visualization systems. So let's talk about a few examples. Next, please. Operational management system. This is a mining site in Canada, nickel site, and they use the weather forecasting for different applications. This is dust handling based on wind direction and wind speed and rain. And so through that applications, they managed to reduce all the nickel exceedances at the nearby community. Another aspect of the weather forecast that they use at this particular site is on the mixing height. Next. Mixing height prediction and inversions, and that's to prevent fumigations. So a very tall stacks, nearly 400-meter high, fumigation in the morning at the breakup of the inversions. So the custom 3-day forecast of the mixing height and adverse wind conditions allowed them to actually schedule the operations to avoid this kind of events. And all this is available through the dashboard with showing the weather forecasting, the mixing height, the different wind speeds, and they use it also for gust and for orders. Next. Talking about mixing height prediction, you can do that in the man side, an open mine side, and it has importance for noise modeling as well as dust transport and dispersion of blast, so for scheduled blasting as well, and reduce dust impact on nearby communities. Next. The weather forecasting combined with the emission forecasting, the noise forecasting, and the dust dispersion modeling, those are two sites in the Atacama Desert in Chile, where we have a full operational system with the weather and meteorology and the dispersion of dust, with a source apportionment showing which roads, which paths, and are contributing the most to the dust level, and then on the flight user-driven mitigation scenarios by the operators. Next. All this on a visualization software where we can bring all the monitoring data, the forecasting, the alerts, as well as video feeds, so that it's customized for the sites, and each operators or each parts of the operation can retrieve the exact data and signals they want for the decision making. Next. On the coastal for marine loading terminal, then it's wind and wave forecasting, gets more complex also for the ocean, and that's in collaboration with Baird. Next. And then we get into the very complicated inverse dispersion modeling for fugitive methane emissions from coal mines and other large area sources. And the challenge there is that it's very difficult to estimate bad emission factors, but also very daunting and inaccurate to actually go in situ. So the solution is to do the monitoring around the mine combined with advanced dispersion modeling and to give to the maps of the fugitive emissions. Next. That allows us to monitor around the mine sites, model the meteorology, do backwards modeling, and then recombine and retrieve the actual emissions of fugitive methane emissions. Next. And it allows the operators to get a 2D site, a 2D maps of the methane emissions with source apportionment for the various sites of the mine. You can do that in near real time, weekly, seasonal, and annual emissions for targeted emissions. And next. And this is how the weather forecasting is at the core of all the modeling, whether it's dispersion, noise, or methane inverse dispersion modeling. Thank you.
Excellent. Thanks a lot for that, Francois. Apologies about the slides not working too well there, but a great innovation there for flexibility and adaptability in the mine plan, and then also for managing the footprint of the mine through emissions and other avenues as well. So thanks a lot for taking us through that. And if anyone has questions for Francois, just pop those into the Q&A box. Moving on now, I'd like to introduce Taylor McCulloch. Sorry, Taylor, take it away.
That's all right. Thanks very much, Sheldon, for the introduction. So I'm Taylor from Endres & Hauser. So Endres & Hauser are a Swiss-based family-owned instrumentation company. And what we do is we provide instrumentation for a range of industries, including mining. But I just wanted to focus on how the use of the most cutting-edge technology instrumentation that you can use will help drive your operation to a zero impact future. So just a bit of background around the trends for water quality monitoring and mining, particularly around the discharge, but we're seeing increased regulation in the industry, a higher level of social and corporate responsibility for mine sites, particularly the larger operators, which are much more visible in the media. We're seeing sites trying to drive efficiency and operational improvements as time goes on to maximize profits. We see the rise of digitalization, additional legislative requirements from governments, and then also there's the license to operate for the operators for mining. Now, all these trends are really driving us towards additional visibility of what the water quality is on site. And as such, we've created an engineering solution to visualize the water quality monitoring on a mine site. So whether it is just basic water quality monitoring panel, you can see on the bottom left-hand side, where you've got maybe a single or a dual parameter system, all the way up to a fully engineered multi-parameter remote panel, as you can see on the top right-hand side. So we utilize our instrumentation and our engineering expertise to create these solutions to ensure that mine sites are actually in real time monitoring the quality of the water and any discharge and also any water balance issues that they might have on site. So by using the instrumentation, you can drive the operation towards a zero impact future towards the end. And I just want to go into a couple of case studies so you can see what this looks like in a real application. So in this example, this is an Internet of Things vendor managed water quality system. So in this case, there's a supplier on site that supplies a material and that gets mixed with water. And the quality of that water is sent back to the vendor into like a cloud visualization solution via 3G. And this guarantees that the vendor product performs as well as it can and also prevents any contamination of the feed water. So some of the parameters that can be monitored remotely using a management monitoring system include pH, turbidity, free chlorine, conductivity, and also level and flow for the supply water. So we've had a lot of success around partnering with other vendors in the MET sector to deliver these engineering solutions as well, so that they can assist other mining operations to ensure that they have zero impact into the future. And you can see examples of that on the pictures on the bottom there. So these are what the panels look like out in the field. Another example as well is this is a mine site which has to sometimes discharge the tailings overflow into the ocean. So we assist with monitoring the tailings discharge quality via a lot of different parameters, including conductivity, dissolved iron, pH, color, and turbidity. The iron includes an automated sampler. So a lot of the times that for other mine sites, they have to take grab samples from discharge into the ocean, then bring it to a lab. By the time that gets analyzed, it might be a day delay or a shift delay. Now we can do that in real time online, and the information is sent back via telemetry straight to the site SCADA. And of course, if the site would like as well, they can go to a cloud solution as well. So now the site has instant availability and an instant visualization of that type of information. So this helps minimize any adverse effects that the tailings gets discharged to the ocean above the regulated limits. So that's just really in a nutshell, some of the examples that we can use for the engineering solutions, but if you have any questions, just type them in and I'll answer them at the end. Thanks, Sheldon.
Excellent. Thanks a lot for that, Taylor. Obviously very important, especially in Australia, to get that water quality monitoring right. And good to see you guys partnering with other METS companies to bring that to the market. So thanks a lot for that. As Taylor mentioned, any questions, just put those in the Q&A box. I'd now like to introduce Hamish Faroush, who will be talking about solid bowl centrifuge technology. Thanks, Hamid.
Thanks, Sheldon. Good afternoon, everyone. I'm Hamid. I'm the Key Account Manager for Mining, Alpha Level Australia. I'll be talking about our solid bowl centrifuge technology. We've been focusing on tailings dewatering using solid bowl centrifuge technology for the last 6 to 7 years in Australia. Just a quick introduction about who we are, what Alpha Level is. Alpha Level is a global company. We are Swedish based. We've been manufacturing centrifuges for more than 130 years globally, and with a presence in Australia for more than 95 years. As you can see here, we serve most industries, biofuels, chemicals, HVAC, oil and gas, wastewater. And our mining journey started about 10 to 12 years ago with my colleagues in Canada, when they faced a challenge from an oil sand company with a huge tailings storage facility that Canadian government, they put a limit for them to either do something about that tailings storage facility, or they have to stop production. They managed to overcome the challenge, and we've got our largest installation in Canada with 18 mining solid bowl centrifuges in there. After that, we started to looking around for opportunities in Australia, and specifically for coal tailings in Queensland and New South Wales. And in that time, that disasters for tailing storage facility breakdowns in Brazil happened. So everyone in mining industry were looking around for alternatives to conventional tailing storage facilities and moving towards dry disposal of tailings. So just I will quickly walk you through the solid bowl centrifuge and what is a solid bowl centrifuge. Solid bowl centrifuge is not a filter. So compared to a filter which has a cut point and it can separate specific size of particles in a slurry, our solid bowl centrifuge can pretty much separate all particle size regardless of size. And this machine doesn't need a dedicated operator. It can produce up to 70 tons an hour of dry solids. It pretty much manages itself through the back drive and gearbox. It measures the torque and adjusts the differential speed in the machine accordingly. So if by any chance you you can see how this machine works. I don't know, Sheldon, these slides I keep going ahead. I'm not pushing anything, but anyway. You can see how this machine works. We get the slurry from the feed tube. It goes all the way through the feed zone, and centrifugal force and G-force starts to separate the solids. And as I mentioned, differential speed between the Sheldon, I think this is.
It's because you got the
just...
videos on animation, so you can just click back if you want to go back. Yep.
Do you want to take control, Sheldon? In full screen, yeah. Go back to the other one. Go back one more. Yeah. So yeah, this is how the solid bore centrifuge look like. As I mentioned, we get the slurry through the feed tube. It has about 30 to 40% solids concentration. It goes all the way to the feed zone. This G-force starts to separate the solids, and the screw conveyor inside the bore pushes the solids towards the solid discharge and the water from the other side. These are some examples of our existing installations. You could see the videos on the left. This is the quality of water we get out of the centrifuge. It could be used, it could be pumped back to the process plant for use. The middle video is the cake out of the centrifuge. It could be anything, cake moisture could be anything between 25 to 40% cake moisture. And on the right hand side is one of our trials that we did with our test rig. You can see the dryness of the cake. It's not it's a spadable cake, and it stack up for stockpiles, and it could be handled by a belt conveyor. So next slide, Sheldon. Again, one of our global targets is moving towards sustainable mining. And by that, what we mean is by using our centrifuge technology, you can dewater fine tailings and move towards dry disposal. And that way you will eliminate tailings dam and all the risk associated with it. Go back one more, Sheldon. And again, compared to conventional tailings storage facilities, you recover water instantly and you can reuse the water in the plant. And tailings storage facilities is a huge cost to mining industry, maintaining them, repairing them, expanding them, and all the risks we have seen so far in Brazil and some part of the Europe previously. It's a big risk to the operations, during operations, and also after, when the lifetime of mine is finished. So go back one more. Sorry, Sheldon.
Oh yeah, you've got the slides on animation, so they're gonna change. Yeah.
Yeah, and again, at the end of the life of mine, again, rehab cost is a big cost to the mining. When you use our centrifuge technology, the rehab cost will be reduced significantly as well. So next slide. What we do, we start with a lab testing. So if it's a new sort of technology, sort of tailings, we normally ask the customer to send off some samples. We could use our small centrifuge we have in Brisbane. We do a spin test, and also we use our skid-mounted P1100 SPC to see how this machine works, and also if it's suitable for that tailings application. We have another, next one, Sheldon. Yeah, we have another larger test rig, P2405. The capacity is 5 to 20 cubes an hour. It's on a skid. It can be moved around the facility for different applications and different technologies. The other one, Sheldon. We also brought one full-scale machine from our factory in Europe. It's skid mounted. It has platforms, MCC, and all the HMI screens. And this is the full scale. It can produce 60 to 70 tons an hour of dry cake. And that's it. Thanks, Sheldon.
Excellent. Thanks a lot for that, Hamid. Great technology there for enabling dry stack and tailings dewatering and the risks and cost factors associated with that. So thanks a lot for taking us through it.
No worries. Thank you.
Excellent. Now on to our final presentation before we get to the Q&A part. So I'd like to welcome Abby McKenna, who will discuss what JWA has been up to. Thanks, Abby.
Thanks, and thanks again. Can you hear me all right? Oh, excellent. I got a bit of an echo. Thanks again, Sheldon, and of course, Austmine, for allowing us again to speak about this really exciting solution that's been over a decade in the making, and we're really excited to announce that we now have the tech in the country, and we're gearing up as we speak to roll it out, ready for our first projects in Australia. So I will get straight into it. There we are. So I'm going to throw a couple of key concept words at you, such as net zero, invisible mine, waterless, carbon neutral, zero footprint, circular economy. Up until now, these concepts have been just that. Oh, my goodness, look out. Sorry, it's disastrous here. Up until now, these concepts have been just that. They've been concepts, great ideas, really wonderful goals that we know from talking to mining companies that pretty much every mining company is working tirelessly towards achieving. And we now have one kit. I'm just trying to find the keys now, Sheldon. It's not there. Hang on, got it back up. So we now have one kit that can bring these efforts from paper into fruition. So to set the scene about the solutions that the tech brings to the industry, let me first briefly take a look at how mining impacts the air, the earth, and the water. Now, as we all know, the mining industry releases emissions to create energy to run their operations. In relation to the earth, mining requires digging into the earth and often leaves behind really big and unsightly and sometimes unstable voids. And then there can also be the knock-off impacts such as soil contamination and habitat loss. And when it comes to the water, we all know the flow-on effects of polluted water. And really interestingly, each litre of water discharged further pollutes 5 to 8 litres of water, which can run off into rivers, into lakes, into agricultural land, table water, and so on. And then, of course, encapsulating all of these different areas is the people, the community. And as we know, community and people often have shared resources with the industry, such as water with the mine. And a lot of our mines are often located in already water-stressed areas. So how do we solve these issues and create zero impact? Here it is. Isn't she beautiful? We do it with the Flamingo tech, and anyone who has seen Hensley present will now know that we have had a bit of an upgrade in the name and a name change to the Flamingo. And the Flamingo technology is a fully automated solar distillation system that recovers pure water and other valued commodities from concentrated waste streams. Now, I am mindful that we only have 5 minutes, and I do know that a lot of you have seen Hensley's wonderful presentation. So I'm going to focus a lot on the big picture of what we can do and how we can now help companies to achieve a zero impact. So the Flamingo, very simply, the first major point, utilizes the sun and multi-effects distillation technology to separate the water from the constituents. Trying to find my arrow again. And this is the first major point, obviously, because using the sun to power the technology greatly reduces emissions. The Flamingo allows you to recycle, to reuse and repurpose up to 100% of water in mining. And the fact that the water comes out so clean means that we're not at all restricted as to what we use it for. So we can return it to the environment for beneficial use, for irrigation, for progressive rehab, for potable water, and of course, reuse in operations as an example. Now, at the same time, we're able to lock carbon from your waste. So you release the carbon and we take it back and put it in the ground through our rehabilitation and our post-mine land use options. Now, really excitingly, we can even extract hydrogen from the treated water and produce hydrogen energy on site, which removes the pollution from the air and of course reduces emissions. Should have worn my glasses. Sorry, everyone, I'm squinting as I go to change it. Now, we're not only targeting direct emissions such as the Scope 1 emissions, which gets a lot of publicity, but we're also looking at the Scope 2 and 3 emissions. So we can dramatically reduce a company's footprint through solutions such as dry stacking tailings and the ability to completely treat the waste on site. So this, and I know a lot of other companies today, I saw this, have spoken about this, which is amazing, results in reducing the impact of waste, transport and disposal as well. So you're getting those secondary reduced impacts. Now, on top of this, we can reclaim the byproducts, such as the hazardous waste and the organic products, and then reform them into something valuable. So as an example, tailing fines can be reformed into topsoil and into building materials, and we can even really easily produce grade A biosolids from your sewage on site that can then be on-sold or utilised for rehabilitation. Now, I know it sounds like our goals are ambitious, but in fact, the Flamingo simply now makes it possible for us to help our customers, partners, and the industry to move into zero impact regarding the air, the earth, and the water, and of course, the community. And now we can do it all with one piece of kit. So we can do all the aforementioned that I just discussed, but what it actually means is now you're not only looking at having a zero impact, it's actually possible to produce a positive impact in site with this solution. So in finishing up, we can and are well on the way to proving this out with our commercial paid trials. And we have a commercial agreements to start working on slithers of this in Australia at the moment. First was dreaming that it was possible. Now we've done that. And I don't know if you can tell by the way that I'm talking, but we're very excited that the technology is now here in Australia and these concepts are no longer a grey area. They are possible. So now that we've got the Flamingo here, just down in the yard being put up as we speak, how we now achieve this on every site is simply a matter of scale and volition. And I will just leave this up really quickly. I did step in for Hensley today. I know we look a little bit different, but feel free to take down Hensley's details or take a screenshot if you have any questions. And once again, thank you, Sheldon. Thank you, Austmine, and thanks everyone for joining us.
Excellent. Thanks a lot for that, Abby. And it's been terrific to see the progress that you guys have made over the last couple of years with that technology. So well done to you and the team. We now are on to our Q&A session, and we do have a lot of questions coming through. So if we don't get to them all during the session, we will follow up with you afterwards and provide a written response to those as well. Alison, I'll start with you. We have a few questions around the circular mine. So I might just choose a couple here that are popping up at the top. But sure. So why, I guess, with the circular mine concept, I guess why was this consortium chosen as one of the the key companies within the challenge?
Sheldon, it's hard to tell exactly what BHP was thinking, but I think one of the things that really stood out about our group was we were a group of businesses. So a group of businesses with a very commercial plan to do real things with tailings as opposed to concepts with tailings. So each one of those different businesses was already bringing a technology to the table that was at least in pilot stage. So hopefully that's what BHP saw in us. And I guess also the collaboration side of things was really strong with our group. It's a group that's been put together by a mine tailings engineer and a mine process engineer who would really like to see tailings no longer be something that is stored on site. So by picking different technologies and everyone having the same goal of a great environmental outcome for the mining industry, I think the collaboration side of things has been very easy, and the technology has helped.
Excellent. And just following on from that, so what are some of the construction materials that you can produce from it?
Sure. So if people want a little bit more information about those, they could Google VITO, V-I-T-O, which is the Belgian version of Australia's CSIRO, which is part of our consortium, and the NEMO project, N-E-M-O. But we can make things like concrete substitutes, is sort of rock, small gravel and rocks, and also building blocks and that kind of thing as well.
Excellent, no worries. And we can always provide some of those links in the follow-up email to the participants as well afterwards. So thanks for that. Coming over to you now, Francoise. So a couple of questions for you. So Charles asked, how far ahead can you make predictions?
Well, you know what the data, you can do it for a few days. You can go as far as 2 weeks, but of course the quality of the forecast decreases with the time. So what we do is that we use the real-time data for very short-term, real-time, and then observations, and then we do the modeling with the synoptic data for as long as synoptic modeling is there, and we refine with the advanced WRF modeling at the mesoscale down to the very fine grid. So up to 2 weeks, but really reliable for the next 3-4 days.
Excellent. And Marianne asked, what type of systems and applications are you using to collect the data?
Well, there's part of it is the data, and part of it is the synoptic weather forecast that we get from, say, NSAP that we refine with our own modeling as well. And so that's met stations, so the RAS data if we have for the meteorology, and for noise monitoring as well.
Excellent. Thanks a lot, Francois. And Taylor, there's a couple of questions here for you, which I'll come over to you for. So Charles asked, can you also include monitoring of underground water and include rainfall and evaporation in your water balance model?
Yeah, so I guess the quick answer to that is we can do that. So in terms of capacity, we have level sensors that can determine by using pressure how much water there is underground in that area. And we can also place some of the quality measurement devices down there, just depending on the geography and all that as well. And in terms of our sensors, they're all using open protocol. So it means that we can customize any cloud solution to input additional sources of information from open protocols, such as rainfall, evaporation, etc. Yeah.
Excellent. And follow-up questions that from Michael is can you detect metals and minerals in tailing slurry in real time?
So the example in the second case study that I spoke about, that it could detect dissolved iron, that's really aimed for water applications without solids in them. There might be some things we can do by removing the solids in the slurry and using the same sampler, or we could maybe work on another device in terms of like colorimetric or density or something else that can by like using a secondary variable, determine the concentration of whatever he's looking at. So maybe get in touch with me and we can discuss it further.
Excellent. Thanks a lot for that, Taylor. We do have a couple more questions, but we will follow up with those afterwards as we are a bit over time. So I'd like to thank the audience for being very engaged and asking quite a few questions there, and also thank our speakers for their time today. Everyone will be receiving an email this afternoon with a copy of the recording and the slides, so you can gather all the information from today in there as well. As also mentioned at the start, this webinar series has been leading up to our Austmine 2021 conference, which is around harnessing intelligence, and hard to believe that this is next week. Quite a few of the panel actually will be joining us at the exhibition floor. So for those attending, you'll be able to see their technology during the conference as well. But as you can see, a great speaker lineup. We have the Ideas Exchange Open Innovation Challenges back with our mining partners, tech talks on the exhibition floor, and also a great lineup for the Industry Leaders Dinner and Awards. So plenty going on during next week. If you're joining us as well and you're an Austmine member, do make sure to book in for the Meet the Miners session, which is open, and also the VIP networking drinks on the opening night. So really maximize those networking opportunities and your attendance at the conference. So once again, a big thank you to the speakers for the discussion today. Well aligned with the presentations and some great examples of innovation driving sustainability in mining. Thank you to everyone who's attended, and we look forward to welcoming you to the next Austmine webinar. Stay safe, everyone. Bye.